Hello and welcome to my gummy bear experiment. My name is Peyton Bean and today we are going to go through two different experiments using gummy bears and some other supplies. So for the first slide we have supplies, which are 3 gummy bears, 1 regular, and then 2 in different mixtures. And then we need salt, bowls, and tap water. So what exactly is the gummy bear experiment? So we'll start off talking about some terms that I'd like to use and that I'm going to use throughout the presentation. So osmosis occurs when liquids flow through a semi-permeable membrane and from a diluted environment to a concentrated environment. So that's going to be really important when we talk about what happens to the size of the gummy bears in the water solutions. And then next we have hypertonic. And a hypertonic solution is when a higher concentration of solutes or solids dissolved in water occurs. And we'll talk about why that's important with gummy bears as well. And then the next solution we have is hypotonic. So hypotonic is the lower concentrations and what happens to the gummy bears during that type of experiment. So I'm going to start off with the saltwater gummy bear because unfortunately mine did not work, I don't think. In comparison, I'll go ahead and show you. So here's a regular gummy bear, very teeny tiny little gummy bear. And then we have, I'll start with the saltwater. So what was supposed to happen and what I may get into as far as what I think did happen and why it didn't work as well. When I pick it up, it's very slimy. It looks like it has absorbed some water. So I'll show you the size comparison. It's a little bit wet. So normal gummy bear, and then I'll show you this. So we have, if I can hold it up, it's a little bit slimy. So it's a little bit larger, and what was supposed to happen is it usually shrinks down due to osmosis causing the water to leave the bear. So gummy bears have a gelatin construction, and that helps to hold the shape and size even when water is leaving or passing through them. But what didn't happen is I think I did add enough salt, I believe, but overnight. I did leave it for 9 hours. And I think maybe the ratio of salt to water was a little bit different. But again, that osmosis where it's supposed to permeate that semi-permeable membrane, I think that it did, and I may have just not put enough salt to water in the ratio. So that is the saltwater gummy, and I'll show you again what it looks like in here. Now, I did leave it for a little bit longer, so 9 hours total soaking, and then of course it took me, this long to do the experiment. So it may have been that. I'm just speculating as to why it could have, and I do believe that it's falling apart, so maybe it had something to do with the type of salt that I used. I'm not quite sure, but it did not do as well as I thought it was going to do, unfortunately. So we're going to go to the next slide, and I'll show you again for reference. This is what this one looks like, and then of course that one, it's falling apart. It's a little bit larger. Usually, like I said, it's supposed to shrink due to osmosis making it shrink and causing the water to leave. So for our next slide, we have our tap water gummy bear. So again, I let this sit for 9 hours, and we'll talk about osmosis in relation to the tap water. So placing gummy bears which have a presence of gelatin, like I said earlier, that contain a chain-like molecule structure, they are semi-permeable. So what's happening in this mixture, so again, small gummy bear. Okay, so again, for reference, we have our regular gummy bear, which is really small, and then this one definitely did work. I don't know if you can see, and I'll put up as far as the size comparison. Of course, in water, it looks a little bit different, but this one didn't absorb nearly as much, but it definitely didn't shrink like it was supposed to. So this one is pretty large, and we'll talk about why that is here in a second. It's not really falling apart, which is pretty cool to see, but it's pretty large. You can see that. Put it back in there. So the reason that this is happening is because of the hypotonic solution, which we talked about earlier, having lower concentrations of solids. So what happens is the gummy bears expand due to the osmosis and that semi-permeable membrane being penetrated by liquid. And when it allows water to pass through, it's allowing the membrane to reach an isotonic state. And what that means is by diffusion, where the molecules are inside and outside of the bear, they become the same. So what's happening is that the water molecules that are passing through, which are using diffusion through osmosis, they're passing through that cell membrane and they're expanding because on the outside they're the same size molecules as they are on the inside, which is pretty neat. I had no idea that hypertonic solutions, or like higher concentrated solutions with solids dissolved in liquids, would prevent something, especially gelatin. I wasn't sure of this experiment at all, that it would prevent that from happening. So that was pretty cool to see. I think that my saltwater situation failed. And like I said, it may have been the ratio of salt to water. So next time, hopefully, if I ever do this experiment again, then I can change that. But thank you so much. I hope I explained everything well, and have a great day.